Hi everyone. Thank you very much for joining me today for our Silicon Valley Python meetup on the Ansible hands-on training. My name is Glenn Jarvis. I've been doing Python for quite a while and other things. And I have several really generous guests to join me today and ask questions. So at any point, guests, if you have a question, please stop and ask because you won't be the only person. I would love to answer questions. And also, we have a couple of questions online. Are we on? As of now, we are online. So that one is done. Also, we had a previous example where someone was testing questions. Also, that is also online. So all questions, as far as I know from online, have now been answered. Really, we're just getting started, and let me just go ahead and start sharing my screen so you can see what we're doing. Please, guests, thank you for joining me. Ask questions as we go along. All right, first I'm going to just start sharing my first screen that you can see, and it is this meetup. So if you are just starting the meetup today, this is the Ansible hands-on training. As much as I do like keeping it hands-on, I find most people just want to watch me go through this repo for the first time and ask questions. So I will happily do that. If you have questions, please do stop me. If you say, I already know most of this and I want a fast version, I condensed about 2 hours into 1 hour and spoke really fast at a previous time, and it's all recorded. So there's a faster recording which I can link to later if you don't want to go through the hands-on, slower, let's explain every piece part. If you want a higher level, quickly go through everything, there's another video that I will point you to. Today is all about hands-on. Today's about taking your time. Today's about understanding each of the pieces. Okay, with that said, this is a tutorial that I made as a repo, so everyone should be able to clone this tutorial or even check out this tutorial to be able to follow the examples that I'm going through. I'm going to make the screen just a little bit bigger so that everyone can see what's on my screen. So the actual URL is GitHub, Glenn Jarvis, Ansible tutorial, and this will also be posted so that everyone can find it if you haven't seen it already. Because this is also being recorded, we want to kind of keep things so it's easier to follow along. So there are actually, like any software, we have releases. We will be following release 1.2.0. There are a couple of examples that have moved, and there are some new examples. So if you are trying to follow along and trying to make sure it's all consistent, we will be using release 1.2.0 of this tutorial repo. You can just download it straight here. All I did was go to releases, or if you really want to follow along on what all the changes are, you can simply go to git clone. This repo, there's a little URL on the lower right hand corner, and if you just type git clone in that URL, it'll give you all of the repo. So today will be a lot of looking at code and going through code examples. Okay? But before we do that, the first thing we need to do is point you to starting a new Amazon instance. I'm going to go quickly for this one because we have recorded a previous video to start a new instance. So if there's any question about this, we'll just hold off on the question for starting the instance and we can come back to that. Do you need Amazon? No, this tutorial can be done with any kind of instance whatsoever. As long as you can SSH with a -i and a key file, then you can use anything else. This has been tested with OpenStack as well, so it works really, really well that way. Okay, so I'm just quickly going to build a new instance. I'm going to call this Ansible training, and I will remember later. Security group. I actually made a security group for this earlier, so I'm going to use this Ansible training tutorial security group. Again, we can talk about those in the future. And as for keys, we will start with an existing key that I made just for this as well. There we go, Ansible tutorial training 2014-08-09. Okay, so all I've done is started an Amazon instance. If there's any confusion by that, I will point you to a different video. We actually spent about an hour. Craig, who also is our guest today, spent a good time. Thank you, by the way, Craig, very much for that.
No, thank you for inviting me.
Oh, no, it was great. So Craig and I went through how to do this from scratch. So if this felt really rushed, like I have no idea what you're doing, Go watch that video, and we'll come back to this video when you're done. Okay? So as that one's building, it's pending. I'm going to need 3 things, and I'm going to need 3 things for my repo. One of those things I'm going to need is the key, which I just downloaded. And that key is in this location. Everyone see my screen? Craig, can you see what my screen looks like?
Yep, everything looks good.
Okay, so I am now listing my key just so I can have the full path for it. So I'm going to need that. So there's my key. I just ls my key so I know it exists. Good. And as for permissions, don't worry. The script that we're going to do is going to handle that too. The next thing that I'm going to need is I'm going to actually need my the username. And if you're using Amazon, it's EC2 user by default. If you are using something else like OpenStack, then it's whatever user that your build is doing. Also, we use the CentOS build to try to keep it as simple as possible. That's what the Amazon AMI is. And finally, we're going to need not just the key and the username, but we're going to need the IP address. Who are we connecting to? And so that is from this machine that we just created. So it's still initializing. It's running a little slow. But the IP address is this one right here. And just to have it on the screen, I'm going to echo it out as well. All right, so those are the 3 things that I'm going to need. I'm in my repo right now, and there's a configure script. If I use that configure script, it'll kind of get me like the bootstrap to get me started so I can kind of learn how Ansible works. So I'm going to just Python configure and let it ask me 3 questions. First, what is my key?
Your key.
Oh, no, I was about to say, you've already got this one. You don't have to worry about this one. So no worries at all. So what is my key? My key is right here. And then my user, EC2-user. And you don't have to configure it. You're already set up.
Yeah.
And the third one is going to be my IP address. And what is my IP address? It is this one right here. So if I've done that properly, it's going to say configuration is complete. If I haven't done that properly, for the things it can figure out, it will tell me. If I have the wrong permissions on my key file, which we all know can be a problem, it'll try to fix that for us automatically. If I gave it a key file that didn't exist, it's going to complain. It's a pretty simple script, though. It can only go so far. So let's actually see how far we can go. All right. So what I've just done inside of this repo, and if you want to follow along, that's great. I'm going into the Ansible tutorials repo that I checked out, into the source file, src, and inside of that into example_01. And that example01 has a script in there to help me test if this worked or not. So if all goes well, and I hope it does, live demos always make me nervous. If all goes well, if I type Python access machine, it's going to try to say, look, I'm trying to access that machine. All this does is make the SSH command for you so it's easier. If you were to copy and paste that SSH command, you don't actually need this script at all. That's all it is. So all it's going to do is execute that command. All right, here we go. Any questions so far?
Nope.
All right, I'm going to go ahead and press return to try to execute that command. The very first time that this comes up is the same thing that we've seen. If you haven't accessed this machine before, you'll see this. Behind the scenes, you have computers that are talking. They don't know each other by cool names. They know each other by, hey, by the way, I'm 548516276. Good to meet you. Oh, good to meet you, 54872555293. But they also have a pretty good idea of who each other is. So I'm going to try to connect, and I'm going to be like, wait, 548516276. He's taller than I remember. Huh. I don't know if that's the right one. I'm going to give a big message saying that's not the right one. I can tell an imposter. I remember him being taller, or machine 542638789. She's more friendly than that, or something like that. So the machines actually know who each other's are, but only after they've connected the very first time. This message is saying, look, I have never spoken to 548516276 ever in my life. So for the first time, do you want me to just trust this is the right one? But I always remember what that machine looks like the next time. I'm going to say yes because there's no other way. If they've never met before, there's no way they can know. But it will remember now, and it keeps track of that. And so next time, I shouldn't see that message. If I do see that message next time, something's probably wrong. So how did we do? Does that make sense for a command? All I did was access that machine by using this SSH command. If you want to see details of how that SSH command works, we actually talk about that in another video about how to set up this for the very first time. For now, I'm going to assume that this is all pretty basic and that we're moving forward, that this first example just kind of ties together the new stuff that we're trying to learn and the old video. And that old video is, hey, SSH, this is the SSH command to connect to that machine. It also shows that it worked. For those who are super security conscious and say, hey, I want to do this sudo yum update right now, don't do it yet, because that's what we do that about 6 different ways in this video. I mean, you can if you want, but you're going to see us doing it about over and over again about 6 other different ways. So let's not take all the excitement out just yet. Let's go ahead and actually do that. Let's not do that at the moment. Let's do that in the next example, actually. So far, we haven't learned anything new. Just to recap, I'm exiting that machine because I was logged into it. And that gets me back at my current machine, the one I'm on, which has this source example 01. And that source example 01 is that first example that we're doing. In fact, I can even make this screen a little bit wider. I have both on the screen for examples later. Okay, so that was just to show that we can connect to the machine. But let's go to example 2. And again, if you knew that SSH command, you didn't need this. All we did, in fact, let me just show you real quick. Let me actually just copy and paste this command. It'll obviously be a different IP address for you. If I SSH that command for me, I should get the exact same output, and I did. Okay? And it got that. It did 2 things. Once, it configured all of the things you'll need for Ansible, and then it actually pulled out from that configuration the things it needed for SSH to try to make it easier for that first step. All right, but all it is an SSH command to connect to that other machine. So example 2, however, example 2 is a little bit different. Example 2 will actually do more. It's going to do an SSH command just like we did before. It's going to use my key wherever it's located at. It's going to go to EC2 user, which is for Amazon.
We have a question here.
Oh, excellent. We have a question. Okay, great. If you have a permission denied is the response after Python access machine, then we can help you with that. That very first time we see the permissions denied is because of the configuration. You need to actually configure first. So I'll ask you to hold off on that one, and I'll refer you to another video for that permission denied. We fix the permissions. In short, your Ansible tutorial training, 2.14.08.09, that key needs to have the right permissions to access. And we have another question that just came in too. Good. So if you guys don't mind, we have some really good questions from online, so let's answer these as we go. So for the permission denied, I'm going to ask you to hold off on that one, Jim. By the way, it was great talking to you earlier. That was really, really cool. I can actually manually work through that with you, or first thing I'll do is point you to another video. I'll ask you to just watch for today as we go through the rest instead. The permission denied is because of something else. But thank you very much. That's awesome to Lee's show. And we have another question that says, would you mind covering how to manage a regular VM under VirtualBox instead of Amazon AWS Virtual? This is a great request. We've seen this many, many times. In fact, we see so many splintering of these kind of questions. We say, I want to see how to do it with OpenStack. I want to see how to do it with Rackspace. I want to see how to do it with VirtualBox specifically. I want to see how to use Vagrant. All of those are great things, and each of them are kind of their own little mini lesson. Really, you just kind of have to pick one. And I picked the one just to be able to explain the Ansible part, because really all this is the SSH and virtual machine part. So what we're going to cover from here on out will work for anything, as long as you can SSH to the box. So for today, I'm picking the AWS only because it's the simplest and easiest to explain to people. because there's a lot of configuration for VirtualBox and Vagrant and things like that too. So not today in this video, but there are lots of requests for other videos that will do that. I will refer you instead to 2 different videos we've currently done, and we'll probably have some future videos for that. One of them is Red Pill, Blue Pill on virtualization. I will have links to that later. Also, the second one is going to be how to build an Amazon AWS instance where you can do it for free and not have to pay anything, so it can go on. But very, very good question. Sorry I can't actually answer it right now. All right, good. Thank you for catching those questions. All right, so it doesn't matter. As a perfect segue, it doesn't actually matter which way that we use to connect to these, because all Ansible does is simply SSH. If you look at all of the other things that are out there, there's a lot of configuration. They're very, very powerful, but they also require to configure tons of things. Ansible underneath does nothing but this. It basically has this part right here that I'm highlighting. You can execute a command on the other machine. Deep inside, all Ansible does is make a file, put that file on the other machine, and then execute that machine like this. So that's kind of why I can sidestep this question we were talking about, because it doesn't matter if it's AWS, it doesn't matter if it's Vagrant, it doesn't matter if it's an open box, any of those things, as long as you can SSH to the box, just like this, then they will all work. All right, so what this command does is it actually tries to SSH-I, the key, username, and the host, but then it tacks on one new thing, and that is execute this command from a shell. So the command is your sudo update, sudo yum update -y. All right. Does this make sense? Any more feedback so I'm not talking so much? Anybody want to help guide the conversation to keep it smooth and slow? No?
Would people be interested in knowing what the T stands for and what the Y stands for?
The Y stands for yes each time. If I were to do a sudo yum update by itself, it's always going to ask me, are you sure you want to do this, and give me all these prompts. The Y says just say yes to all of those things. But good question. The -T says a command is coming.
Why did they pick T?
I have no idea. Because they ran out of letters, I guess. No, I don't know. It probably actually is. It's a very good and meaningful question. I just don't know the answer.
It's easier to remember.
Yeah, it is easier to remember. And frankly, I have to look it up every time because I don't remember. If I had that mnemonic, I would probably know. So, homework. Go find out and come back to me, and I'll tell you next time. All right. So it's going through the sudo yum update. Is this executing on my machine or on another machine? Anyone want to pipe in? Is this executing on my local laptop, or is this executing on the Amazon instance that we have?
It's executing on the Amazon instance?
It is, because on my laptop, I'm doing an SSH-T on that other machine over there. And it's really important to remember that, because what we're doing is I'm running commands from my laptop to control another machine. And I don't have to control one, I control hundreds. But yeah, that's it. So I just updated that new virtual machine that you saw me build, that 548516276, which won't be the same for you, and it won't be the same for me the next time I do this. Are there any questions? Does that make sort of sense?
I'll give you an answer.
Oh, we have an answer to the -T question.
For sudo TTY allocation.
So the T would be the sudo TTY. You know, that actually makes a lot of sense now I think about it. So TTYs are these type of terminals, and it goes back to historical Linux, but if you know what a TTY is, your -T will help you remember it's kind of like a TTY. So it's kind of like answering something on the terminal. All right, so I will be, the same point is fundamental to everything else, and that is, and I'll just do this command again, it doesn't hurt. That -T command, all I did with this prompt is just kind of step you through so that we can kind of go through the next piece. I just interrupted that so I'll clear my screen as well. All I'm doing is running a long command that is basically saying, connect to this machine with that username, with these permissions, because that's the username that has those permissions, and run this command, sudo yum update -y. And that's all it is. And I don't even have to do that from the command line. These examples are just kind of building that for you. It looks different this time because, frankly, we already updated it. That's why I was saying earlier, don't do the sudo yum update yet. You'll take the fun out of this example. Okay, so it's already done. We've updated that machine. Unless we happen to hit where Amazon's coming out with a new package at the moment we're doing this video, we won't see that do much. But we're going to try it lots of different ways just to show how that works. All right, all I've done now is move to a third example. This example, example 3, is, let's take a look. You can follow along in this tutorial you want as well. So this README file kind of tells you how it works. So we've now established that you can issue SSH commands remotely. And I actually spent a lot of time talking about that. Why? Because I keep wanting to illustrate this point, deep inside is underneath, that's all this is. It is actually just doing SSH -T under the hood. So you'll notice that this particular example isn't anything to run. You could try to run it, but it's going to give you an error because unless you happen to be on an Amazon instance that matches the same, unless your laptop or whatever you're working on is the same as an Amazon instance. Because what we're doing is this is actually a module that Amazon, remember I said that Amazon puts a file, it creates a file and then it moves it to the other side? Well, this is an example of that file. So I was watching as this was working. I grabbed that file. It wasn't called Ansible module. I just made that simple for you. But I grabbed that file that was being executed from the other machine. So what Ansible is doing underneath is it'll take a file just like this one. It'll move it over to the other machine, and then it'll run a command to execute it. And there's nothing simpler than that for these machines. And that's the reason this particular kind of deployment is so simple. Now, this file looks very complicated. It's not as much as you think, but we're going to bypass what this file does until the very, very end, or actually a whole other section, because you can learn to write your own. For now, it's not important to learn what this file does in code, only that this file is something that Ansible will create for you and move across. When we learn to write our custom modules, we will actually learn how this module works. But I'm going to go ahead and try to execute it. And if I do execute it, I'm going to get an error message, but notice, it's not a bad error message. It's JSON text. So basically, it's going to tell me that there is no such file or directory yum update. And the reason I see that is because I'm actually running this on a Macintosh OS X, and I don't have yum on a Macintosh OS X. So that's why I saw this particular message. So that's also showing that this particular file wasn't meant for my computer. It was created and moved across. In fact, later you can recognize when we start getting into things called modules and shell modules that this is actually just a shell module that happened to be shipped across to the other machine. The command of yum update was given. It returned a return code of 2, and it even tells you whether it failed or not, and even gives you the output of the message. So does this even have to be done in Python? No. This tool is written in Python, but it can interact with any particular piece of code. As long as that code can be executed and can return to the standard output a JSON string, then that's just fine. So you can write this in Bash. For those who are so keen of saying, I want to write this in Bash, you can. For those who want to write this in Lisp, you can. You can write it in whatever you want. All right? All right, so I'm going to go ahead and move past this. We only dipped our toe in the water here to just understand that one concept that I've been hitting so hard because it's the most fundamental one. At some point we're going to get tired of hearing it, we probably already are, is that all we're doing is moving files across and executing them. Whatever those files are doing, we're calling them modules, they're not Python modules, but that's what we're doing. All right? So that's how Ansible works underneath the scenes. I'm on 4, right, Abe?
You just did 3.
I just did 3. Okay, good. Thank you. Everyone here in the office is keeping me sane. I really, really appreciate it. All right, so we're moving past SSH now. Could I build an entire set of systems out of SSH? I have in the past, and tell me I had a headache every single time. Ansible only just makes it easier, because every time I tried to do this, I didn't keep these ideas of idemnipotence, which we'll get into. I didn't keep these ideas simple, so I have several times built a software installer that actually did all of these components, and I would always spend so much time waiting for it to build and not actually writing code. So we've actually been able to get our way around that. All right, SSH is going to be done for us. We no longer are going to think on that level. Ansible is the command line. Web servers is the group of machines that are actually going to do this for us. -A is the actual command, and just to keep it consistent, I've been doing the same command over and over and over again. So we're going to do this a different way. If I had 500 machines controlled by Ansible, and don't even have a Ansible module, I just want to run a script across or a command across all of those machines, I can do so. Now, with only one machine, it seems to lose some of its power. So let me actually show you what my Ansible host file looks like. That Ansible host file, oh, and let me try to move this down so that people can see it a little bit better. That Ansible host file is really a whole series of machines. So let's say I have 500 web servers. Sorry about that beep. Now, I just made that up. But if I had all of those different IP addresses that were my web server, then I could control those. And what if I didn't have just web servers, but I also had database servers? And then I had web servers, database servers, and some type of application tier servers. Or now I have Memcache servers. So I can start controlling my infrastructure. But just to learn, we're going to keep it super simple by just having this first machine. And just to make sure I didn't change it, let me get out and go back in. Yes, that's the original file. I don't want to change it because I'm doing a demo. But all web servers is, in our example, is my one machine. We had tons of them, then they would all run. All right, so my README file says, let's run this command. Ansible web servers. Again, you saw from the top that section of files for web servers only has one machine in it, but it could have hundreds. And then run that same command. My boss just came up to me and said, Glenn, we have a problem. There's a security patch that needs to be taken care of, and we have 500 machines in our infrastructure.
There's a question.
Okay, cool. There's a current question that says, this assumes that they all have the same SSH keys. In my example, in tutorial example, it does assume they have the same SSH keys. It's a very good question. Let me come back to the file I was in a second ago. I actually could also put, I think it's called, I can't remember the exact parameter. I don't have to have the same key. In my configuration file, I can have different keys. So I can actually have different keys in my inventory file here. So basically your Ansible host is your inventory file. It can be super simple like we've done, or it can be super complex, keeping track of these variables for each host. And it can also be dynamic. There's a way to basically have this file not be static, but any program you want, so they can interface with anything else. And as long as it returns JSON text when it's finished to standard output, like the rest of Ansible does, then that will work too. But no, I could have actually specified a key here and a different key with somewhere else. Did that answer the question? Right. So just had a good question. I assume that we just answered it on does that have to have different hosts? I've lost my mouse. There we go. Sorry about that, everyone. I got a little off trying to answer that question. And I did mark that question as being answered at the time I was speaking. So just go back a little bit in the video and you'll see that I just answered the question about does it have to have different keys for each one of them. So with that said, I can actually run this Ansible command. What does this Ansible command do? It's basically saying I can run this command against everything in my web servers. And I was about to spin off into, oh, good. So did it answer the question? It looks like it. Did it answer the question? It looks like it just did. So I was just about to say, my boss just came to me and said, Glenn, we have a great big problem. That problem is we have all of our machines, a security update was just announced 2 minutes ago, and I need you to hit every web server we have, and it has to be done like today, and we have 500 of them, and I need you to run this update against all of the commands. Then right now, assuming not only have the same keys, but also assuming that those different machines all have yum, but assuming that that's how I've made my architecture, then, oops, wrong command, then this command will work and update all those machines. I'm going to do just one though. Ready? Here we go. So we're going to see the same thing being done before. And that is that we are just running this update. But now we're getting a little bit more of the nicer output. The list of the machine that executed, whether it was successful or not, and the return code, and some other things of what happened. So this is just how it's just running a command against all of the machines in my host. Let's say that that failed, and I had to try to figure something out. So if that failed and we had to figure something out, then I can actually put another V option in. A single V just says, give me more verbose output. Except I did it wrong. 1 second. The A is telling me what command, so the A needs to have the string next to it. The V is separate from the A, or at least before the A. So if I run this with more verbose output, I don't see a lot of verbosity here. It's kind of like the default level of verbosity. But if there was a problem connecting or something else, I can even say, give me more verbosity. Look, I'm going to remote module. Hey, look, I removed a command over there, and then I executed it. Same thing I was saying. This is how it's working. That's not enough verbosity. I don't know what's going around. So give me even more, 3 levels of verbosity. I want to see more what's going on. All right. I establish a connection to that user. Hey, that's the wrong user. That's the right user, things like that. Then I have this remote command, sudo yum update. Here's the exact parsing, and if you're used to Python shlex, you can actually see how it's parsed out of the command that's going to be executed on the other side. Pretty big command, but that's all it's doing. It's going to put the file over there. Not exactly the prettiest format for the file. It's temporary, and it'll be erased when it's done. It's actually going to execute it. And then it's going to grab the results and print it out to you. So if I get stuck, I can always have VVV. All right, we start off very, very slow with all of these examples, but then we start building quickly as we go along. The idea is we want to be able to show a fundamental understanding of the basics so that we can see what the rest of it goes on. Are there any more questions with how this works for the Ansible command? It really is just the same thing that we've done with SSH, but seeing that Ansible is doing a lot of things where it can actually control the machines for us. Okay, so that's all, and I can put any command I want. But that alone isn't that useful. I mean, it is, but because I have the inventory. But by itself, might not be all that I want. What if I actually want to say, look, great, I can run execute commands, but I really could do my own little SSH stuff and my own management of files, and I don't really need Ansible. What I want is something more powerful. I want to be able to use this built-in stuff that comes with Ansible. For example, I want to use something called modules. So this command is slightly different. We're using Ansible again, but Ansible itself is going to run a module, and that's what the M is for. It says a module is coming, and this is the name of the module. And then the actual host, again, just like the host file, I can have a whole group of servers. This group is going to be the web servers group of servers. So if I wanted to say, okay, how many of my web servers are up and running? Can you please ping? Glenn, please ping all of your web servers. I want to see if they're running or not. Thank you very much. I can say, sure, not a problem at all. Here we go, Ansible -m ping web servers, and all of those hundreds, or in my case just 1, web servers being pinged. And the results, I get a pong. So ping, hey, did you get results? The response is, yep, pong. What's different is that instead of actually running a command, a very special, like one command, we're actually going to say, here's a custom module that is going to be executed, and that custom module in this case is the ping module. We'll start getting into what modules are really soon. In fact, the next example goes into a more useful module. But does it make sense how this is different than the previous one? The previous one was executing a command which can be anything on the shell. This one is going to be something, these files that are built into Ansible, they aren't really Python modules alone. They are just a special thing that Ansible has that we're calling modules, and they're built into the things that run across the other machine and execute. So ping, for example, is going to do things on the other machine and actually execute the results and send a response back.
What does Ansible know where to find ping?
Ping, it has a built-in list of things, so the tool itself, it builds ping, creates ping, puts it on the other machine, and then runs that command.
But when you run the command that you just ran, Ansible finds ping on your laptop.
That's right.
Sends it to the server. How does Ansible know where to find ping?
Because, so the question is like, how does Ansible know where to find ping? Because ping is actually a file, not necessarily a Unix command on the other machine. It's actually a file it's creating. It's going to SSH that over into a temporary directory that it knows about. So it knows from the last time, it just SSH'd it over there to a particular location that it picked. So it knows how to find it because it just SSH'd it to that exact location.
No, not how does it find it on the machine you're connecting to. How does it know how to find it on your machine?
It built it.
So it keeps track of all that.
Yeah, that's built into Ansible. Yeah, so the question is, how does it know what ping is? Is that inside of Ansible you have a lot of these built-in modules, which we'll get into. Ping is a special library, if you will. Think of it like a Python library where, you know, how does it know to import logging, or how does it know to import CSV? It's all built in.
So you didn't actually create ping by yourself using an editor. You used Ansible to create ping.
That's right. The question is that I didn't use ping myself. In fact, I didn't do anything to type this command. Ansible has a built-in ping, and I just used it. Good questions. I like that. Keeps it more interactive, too. All right, so any other questions on how modules work? They're this thing that we're just learning about, and we'll spend the whole time learning about more and more modules as we go. But just the concept of a module is things built into Ansible that make our lives a little bit easier. In fact, I'm going to show you a new module. Real quickly, I have moved to example 6. So these are small examples that we have running. These examples are kind of like bootstrap examples to get us started. We're not going to use the Ansible command later. We're only using this to kind of see how it works, to get the guts. We're going to start picking it up and start seeing what's going on in a few minutes. So the Ansible command that I'm going to show you is a new module. This module is called setup. So let's take a look at it. Now, I always got confused the first time I saw this module because I thought, oh, what is it doing as a setup? Don't think of it that way. Don't think of it as it's changing anything on the server. Just think of it as retrieving information. What is the setup of that other server? So it's going to try to go gather a whole bunch of information, gathering facts from that other server. What is that other server set up? And it gives it to me in a very Ansible standard way. And that way I can actually, like, say I have this machine on Red Hat Enterprise, this machine on CentOS, this machine on Gentoo, because that's what I do, this machine on something else. At least, even though there are some things like Yum that won't be standard.
We have a question.
Even though we don't have things that are standard for everything else, we at least have a way to make it standard between all the machines. Okay. So the question is, so Ansible minus ping web servers and Ansible web servers minus mping is the same. Why the different formats? So the question is, Ansible minus mping web servers and Ansible web servers minus mping is the same. Why the different formats? That's actually just a Unix command line options. It doesn't matter. In Unix, you can actually specify command line options in different orders. Did I do it differently in my slides? If so, then I should find that and I should fix it. What did I type? I'll look to see if I did it 2 different ways. I want to keep my slides consistent just to keep it less confusing. But as far as Unix command line is concerned, it doesn't matter. So really it knows the -m setup is an option, and then the final arguments is going to be web servers. Okay? So let's try this. Let's try a setup. Give me a second. I'm going to come back to the screen, and I have setup as my module, not ping as my module. So I just ran that, and I got a whole bunch of stuff. So again, setup is really useful. It's like, what exactly is Amazon doing right now? How many actual processor cores do I have access to? It looks like I have a processor count of 1. Yes, these host keys that are public and private, for those who are very, very savvy that I left those exposed, I make a temporary key and throw them away. Some very, very savvy people know that from previous videos, hey, by the way, this shows you get to see all kinds of stuff. I make a brand new key and throw it away right after the video just to avoid any kind of issue like that. So no concern there, but typically you would not want to display some information to some people, or at least so publicly. So what else? Look, I have an address. I have a net mask. I have my environment. I have some IPv4 stuff compared to something else. I actually have the time and date that Ansible worked. I have this Ansible architecture. The details of all of these you can always go look at later, but the point is that you typically want to just be able to have this and look at it whenever it comes up. If you need something specifically, you can go get it then. Also, really the point is I want to show you that these modules can do a lot of things. It's not just a POM command. It actually can be a lot of built-in stuff. This is not just a single command. So really we've just talked about commands so far. Does that make sense? That we have commands, that we have been running commands, and that Ansible commands can do things.
Makes sense.
All right, thank you, Craig. Awesome. Now, I have been going a little slower than normal, only because I didn't have feedback that someone was saying this is too slow, we get it, which is good. Also, I wanted to make sure that we had some really good questions. I want to make sure everyone fundamentally understood how it was working. So these are make sure I'm right, that this is the last of the examples I've made. Yeah, this is the last of the Bootstrap examples. I will no longer belabor any points about how SSH is working, how Ansible-A is running commands across the screen, to the other machine. I won't actually say, oh, look, this is how we're actually running modules. We will talk about modules, but we won't be actually using the Ansible command anymore at all. All of this could theoretically be done with some good SSH wrapping, but it's not really the power of Ansible. The power of Ansible comes in what they call playbooks, and this bootstraps us to get there. So unless I have more questions, I'm going to now move to playbook examples. Any questions? Sorry about that. Let me try to move this up. I don't know why that's suddenly showing up here. Give me a second. Make that a little shorter so it's easy for everyone to see. I'll move it down so it's not covered up by the top either. So we have several other examples when it comes to playbooks. So the very first playbook is going to be this first one called iter01. Notice that playbooks are just YAML. YAML is just a configuration. So if you've ever heard of something called JSON, or if you've ever heard of just a Python objects, all of this is just another way of representing data. And so really this is just a dictionary where you have host and tasks as the keys. From a Python perspective, or Ruby, this is just a hash. All of that's just a fancy way of representing things in human readable format. You could represent in XML as well, which is not very human readable. But this is human readable format of data, which is called YAML, yet another markup language. All right? So really we have two things. We have something called tasks and host. Hosts are the same thing I kept talking about before, where we had web servers, and then tasks are things where we actually can start executing these tasks. Tasks are going to have a couple of things. Having names on tasks make your output a lot easier. And so I always will put a name on my task, and it actually can be used to kind of reference tasks before, so it's almost like a key. And the shell is going to be what command is being run. So yes, yet again, we're spending time talking about yum update. But that's just so we can start seeing things. So a shell module happens to be a module that will execute something on the other machine. There are lots of modules besides this. Sudo means I need sudo to be able to execute this command. The command to do this is called Ansible playbook. So if I actually do Ansible playbook, demo playbook iter01, it will actually start running that. Notice the very first thing it does is gather facts. That's that setup module. It's just gathering a lot of information. You can say don't gather facts, it takes too long. But usually you want to let Ansible gather its facts to register those variables because you may use them in your plays. The next thing it does, it says make all the OS patches that are applied. That's the name that I created earlier. Also, notice that it thinks it changed something. Shell modules are just command prompts. Unlike before where I actually just ran things, I could never tell if something changed or not. Shell commands that are being run, they actually, Ansible's not smart enough to know whether the operating system changed something on a shell. But if I were to use a module, it is smart enough to know. So it says, because this is a shell command that just executed command, it says, okay, that changed. And it registered that that changed down at the bottom in my recap. So my playbook, when I ran it, gathered facts. I can turn that off. 2, it ran the task I just told it, but it thought it changed it because shell prompts, it doesn't know that shells can or can't be changed. Other modules, they're smart enough to know the difference because they can keep track of what changed. So modules can be much smarter. How many hosts are unreachable? 0. I only have 1, so I wouldn't want to see that to be too large. How many hosts actually failed? None. The command was successful. 2 total things changed because gathered facts was executed. Oh, I'm sorry, only 1 thing changed, but 2 things were executed, gathering facts and tasks. So it's yet another way of doing that same yum update. Why focus on yum update? Only to try to show you how Ansible is changing and to keep the command the same, to not throw too much at you. I think that we're ready to start changing things. We'll do a couple things that are like a yum update in different ways, but then we're going to move to something outside of yum. All right, I don't see any more questions, so I'm going to go ahead and move to the next example. Demo play, whoops.
Oh, you're in the wrong.
Oh, thank you.
You CD'd.
I CD'd upwards. Thank you very much, everyone. Sorry about that. I'm so used to going up and down between examples. So I'm actually have a different playbook, and I will actually start putting my screens up so that you can see playbooks run as they get slower in one terminal while we're looking at them in the other. For now, I'm just going to look at this one. So look, I have a shell module. Again, all the modules are listed here, and I can put 2 tasks together. The very first one does that same update yet again, but look, I'm actually going to use something else. Again, I'm using shell, so it's going to say yum update -y get. So now I'm installing get on the other machine. I've updated that. The other machine's getting bored. It's heard me updated the operating system a million times. Like, okay, I'm updated. Don't worry about it. But now it's actually going to have something installed, and we should see something happening. So let me type. And I know that this is a long command. Sometimes people say, can't you just alias it? For this demo, I'm not going to, just because I like enforcing the fact over and over and over again, and so you can keep seeing that command. So the first ones went fast. Gathering facts, that happened. Task operating systems, that happened. Installed our AWS Linux, that also happened. So it actually changed something because it had something new to change. But because it's the shell prompt, it doesn't actually know the difference. It thinks that all shells have changed. So, gathered facts looks successful. 3 things happened. I gathered facts in 2 tasks. 2 things changed. None of my hosts were unreachable, and none of them failed. Pretty good. I should have get on the other machine. In fact, I know I do. So, I don't see questions. I'm going to move to the next playbook. Now, how is this different than the previous one? How many tasks are included here? You can start seeing that so far we've really just been talking about tasks, but now we can actually start including things. So this playbook can actually include an entire other playbook. So when this playbook executes, the first thing it's going to do is go run the previous playbook, demo playbook iter01. And then it's going to start running these tasks right now. So that playbook is running, and then it's going to execute. And that first example, all it did was update the operating system. And then this task, again, it's shell, so we keep sticking to the idea of the shell. It all looks like it's changed because it's not a module that it knows the difference about. And then it's going to execute a script that's going to execute or install get. Is this really going to change anything? No, get's already on the machine. It didn't actually change anything. Shells don't know the difference, but it'll look like it changed. How many tasks do you think this will see? Anyone want to take a wild guess? No, sorry. How many actual things do you think it will see? How many tasks, how many different OKs do you think will be on the screen? Sorry about that. So it gathers facts. It updates the installed stuff. It gathers facts again, and then it updates get. The exact same thing it's done before. Basically, update your OS, and then install get. It still looks like 2 things changed because they are both scripts. It doesn't know what really changed or not, so it just considers it, okay, it's probably changed something. But 4 things happened. It gathered facts twice. Why? Because I actually ran 2 different playbooks. Really, I ran 1 playbook, but also that playbook ran the previous playbook. Any questions so far about how those playbooks are playing? That was 3, right, Abe?
We just did 3, yeah.
Okay, good. So let's look at 4. What is the difference between this one and the previous one? Very hard to see until you know what you're looking for. What's the trick? Anyone want to tell me real quick? Or shall I, before I bring attention to it, anyone see the difference? Forcing us to think and not just listen, because I can talk, as I'm talking, it's so easy to kind of, just say, instead of challenging what I'm saying, is that true or not? What's the difference between that particular one and the previous one?
It's not an actual command.
This is not a shell module. This is the yum module. This entire time I did not have to be using shell. But I did that to show how we can just, SSH worked and how we can just kind of build that up. This is a module internal called yum. And that has to be idemnipotent. Don't forget what idemnipotence means. When I did this before, by doing a lot of shell scripting, I didn't have this idea of keeping the tasks small and keep them idemnipotent. If you can run a task 100 times, it shouldn't change it any differently. After I'd run it once, twice, 3 times, it really should be okay to rerun it, and it shouldn't have a different effect every single time. That way I can just focus on this task alone, kind of like extrapolation, if you will, or extrapolating it into its own little concept. So if I can just focus on that thing, then I can focus on it and then later string them together. So this means that the state, at the very end, no matter which time I ran it, the state needs to be present. And the name that is going to be get. Every module will have their own custom things, and we can see from the documentation what those things are. So the very first time that I ran this, the state, it wasn't present, but after I was finished, it was present, because it installed it. The second time I ran it, it didn't change anything, the state was still present. The third time, the state was still present. Make sense? So as long as, after I run this, it will always be present. And it will know whether it changed it or not. Do you think that will change? That particular yum is smart enough to know if it changed. Will that git install change anything? I see head shaking no here. No, because git was already installed previously. So now we see changed move down to 1. We had several things happen. But because it actually was smart enough to know that it was installed enough, I can actually see if something actually happened or not. Okay?
That's a sneaky way of using an if state. Behind the scenes, it's really yum is using the if state.
In a sense, there's actually some more sneaky ways. I want to reserve that sneaky ways for if statements for the end of these when we get to like 13 and 14. But yes, it's a way of basically saying I don't need to care if it's if or not. I just need to say at the very end, I don't need to think about it anymore. Keep it easy for me. When this is done, it is installed and present, and it won't break to run it 13 times. So I can actually have other things run it, and it's okay. Any other questions? All right, so let me go ahead and VI. Craig, are you still there?
Yep, I'm still here.
Good, just checking in, making sure that we didn't lose any connection. All right, so this one is a little bit different in that now we are doing this. What did we just do? So we are doing an include demo. So we have several things that are included here. One, we include the demo playbooks iter1. So that means that we've included a previous playbook, the first one that used the shell to update yum. We're still using the hosts of web servers, but we have this new section called variables. So I'm going to have different variables in the system. One variable is going to be, I made this variable up, said our desired web or package name is going to be get. And so down here, this task is going to basically say yum, this is the new module, state is present, name is going to be whatever variable. And look, if you're used to Django or Jinja kind of substitution, all this is doing is just substituting variables through strings. So basically it's first saying, look, there's a variable, let's pop that variable into place. So yum, state is present, name is get. So yet again, we have found a way to run an update and get. Okay, so I'm going to do that real quick. Ansible playbook. Going to gather the facts. It's actually going to make sure the OS is already installed. It already is. It's going to gather facts again because it's the original playbook, and then get was already installed, so it's already there. So same thing. So now let's look at 6. Building up through our examples, what did I just do? Someone tell me what just happened. It looks really short, and I'm confused. Not really, I'm just saying I'm confused to get people to talk to me. Anyone brave enough to stick their neck out and say, hey, this is what happened? It's okay to be wrong.
Oh, I'm ready to answer.
Oh, Alex is ready.
But I've cheated. I've been here before.
Well, that's all right, Alex. What's happening here?
Well, you just substituted your variable. You've assigned a new variable, and it'll execute now with the new variable. So you'll install Nginx instead of Git.
That's right. Basically, I'm now found a way to reuse. I can reuse a playbook, and just like we had variables that we overrode for hosts, we have variables that we can override in the include. So I can now start selectively including things, and if I write those with variables, then I can overwrite those variables, and I can make this even more modular. So we start off with something like a bunch of shell scripting. Then we get the idea of being able to modularize with different playbooks, and then we start seeing how we can modularize with actual state modules, and then we actually start seeing that we can start including other playbooks in by substituting. So the trick question, which is not much of a trick question now, but I'm going to still ask, is what package is it going to install? What package is that going to install? And the second question, will that change? Look, just like Alex said, we just installed Nginx, not Git. So yes, it legitimately had a change. One of those was from just that OS from the script, and the other one was the Yum really did make a change, and it was smart enough to know that it did change. Okay, no more questions, so let's go to 7. We're on 7. We're starting to really complicate things a lot. We have 3 tasks, not really complicated. So what's different between this one is that we're going to use the shell to update, we're using Yum to update, and now we have a brand new module, service. So I have installed Nginx, but it's not very useful if I haven't done anything with it. So if I've installed Nginx, does it start? If I were to look at that machine right now and see what its host is, I bet you that is not installed. Oh, I know what happened. I got my screen on the wrong side. That's why this is over here now. So my Nginx isn't installed. My Nginx is installed, but it's not started. So if I were to basically say the state is started, but the name is Nginx, services will be the same thing as sudo services start Nginx. And here we go.
We have a question.
Oh, good. We have a question coming in. Can you make a playbook prompt for the variable value? Can you make the playbook prompt for the variable value? Oh, yes, you can actually. There is the. Let me select this so people know I'm answering this question. So selecting. The question is, can you make the playbook prompt for the variable value? Yes, you can. There's sometimes you want to say, look, ask for a password. I can't remember off the top of my head, because it's not one of my examples, what that is. But we will get into debug soon, and I think there's something that's called interactive. We can look that up soon. But yes, you can ask for it, take the responses, and then use them in your playbooks. Useful for things like custom passwords and things like that. Very good question. All right, so If I dare start this where I was, I'm going to start another terminal for a second. What I'm doing right now is that no one can see is I'm actually going to start a new screen and drag it over. I realize that my command screen got put onto the display, so you can see this. And what's the name of my host? It wasn't started before, and this was a brand new machine that you saw me build. So will I actually see something? Hey, we have Nginx. Nginx is running. That's pretty cool. So from scratch, I was able to start Nginx and get it running on a machine without actually logging into that machine, except for the very beginning, just to show that we could. All right, so that is example 7. Let's do example 8. Now, here's a trick question. I like throwing people off and making them think someone needs to be brave, even if it's someone here. How many tasks is this going to run? And I tell you, it is tricky on purpose. Anyone want to take a stab at it? How many tasks is this example 8 going to actually run? Someone say 3. Someone be bold and say, oh, I'm going to fall for your trick, Glenn. It's 3. I'm waiting a little bit because I see a lot of good thinking happening. So for those who are paused and watching, there's a lot of people are really looking at this slide, which is good because it gives us a chance to think about it. How many tasks do you think we'll see here?
Just the one.
Okay, I have a vote for 1, I have a vote for 2, and I have a vote for 3. So let's see what the answer actually is. All right, so we are gathering the facts. Now, I'm not counting that as a task. That'll be something that'll say okay, but I'm not counting that. There's one task, and then the second task for installing. So the answer was 2. Why 2?
It said 1.
One change or one tasks?
One change.
Oh, I'm sorry. I'm asking how. Okay, for those, you guys are well ahead of me. You're actually being more specific, not even saying what's changed, but you're actually saying how, what, you know. Okay, very good. One change, you're exactly right. In fact, right here it did say change equals 1. What I'm really saying is how many of these things are going to run. We have gathering facts, so we'll take it off. And then we see these 2 right here. So make all the OS patches are applied, and then install the... So what happened to my services? Why didn't this guy run? The trick is that it's not a task. It's very easy to see that, right? Or very easy to get confused by that. I do as well when I see this. Handlers is not a task. So far we've learned several concepts. We started with these ideas of modules that we're seeing built into tasks. And then we see playbooks that have these things like hosts, variables, tasks, and handlers. So what is a handler? A handler is nothing but a special task that can be executed when a task finishes successfully. So it can be conditionally handled. So it is a task. It has the same format as a task, and it runs as a task. It's just not called a task because it's a very special one. It doesn't run with task. It only runs when it gets notified. So nothing told handlers to run. Nothing told this Nginx services to start. Now, Nginx services was already started, so you guys were very, very sharp to say, hey, look, we already know it started, so nothing's going to change. But it didn't actually do anything. It didn't execute. So how do we get to trigger handlers? And this one's a little mind-blowing. Take a few moments to look at this one. So we have includes, we have hosts, we have all these handlers. Look, these handlers do things. And there's another module. So we've seen a module of yum. We've first seen the module of shell, which will take whatever argument you give it as a string and execute it on the other side. We see yum, which will take different, and every module needs to have these different things, like these key value pairs. So yum had a key value pair of state equals present, name equals Nginx. We saw a services module, which was like this one, which was state equals started and name equals nginx. But a new module is the debug module. Every module in the documentation, you have to look, everyone has their own documentation. This one has a message of, or this one has a key value of it looks for message. If you don't provide it, it will just say hello world. So that will actually, just like doing prints in Python code or something else, it'll actually print out something else. These, although, are handlers. These handlers are actually not doing anything themselves without being called. This is the only task that is executed. If this task registers a change, then these handlers will all be notified. So, will this task be registered as a change?
Well, the echo will be changed.
Yeah, but how?
Just the shell.
Because shell will always see exactly. Shell is going to make a change. So, of course, I'm going to write the example that's always true, just to keep it simpler. So, when we execute this one, oh, and one more thing to notice. Look at the order. Oops, I'm sorry. Give me a second. I was in 9, right?
Oh, yeah.
Okay, so when I look at this order, we'll actually see that these are the order that they are listed in handlers, and these are the orders that they're notified. The order may surprise you. So let's come back and look. In fact, I'm going to start running this here, and I will start looking at another window. Ansible Playbook, it's running, and while that's executing, let's start this split screen so we can actually see it in another window. Oh, I'm still on that machine. That previous machine. Okay. So let me go to Playbook examples in this window. And while we have the thing on the left, let's look at example
9.
Okay, demo 9. So we have demo 9 on the right in the text, and we actually have what executed on the left. So notice that it gathered facts. That happens on every one, especially because we included one, so that's where this gathered facts comes from. This show something special was actually what we showed with the playbook in 5, which we actually used variables for nginx, so that idea is combined. The host is web servers. The variables are going to be demo message of hello world. So we're starting to combine a lot of concepts together to show you how they work and how powerful this can be. But notice that the notify start nginx, so we notified print or not. That was not start nginx. Print or not was second. This notify list is not the order of notification. It's on order defined. I'm not sure why. So questions come up a lot, actually. But it's a gotcha that I did run into. 2 gotchas. 1, if you don't call your handlers, they won't execute. So you actually have to notify handlers just like we did now. And 2, the order of your handlers will change depending upon, well, actually, the order of your handlers will be fixed on how when they're first defined and not how you set in the notify here.
So they will be in a predictable order, not predictable by the notify statement.
Exactly right. They are in a predictable order, but not in the notify statement. Maybe that was why, to make them in a predictable order. I'm not quite sure. It's a question I still don't have an answer for. So I threw a lot at you on this one, and we still have a few to go. How much does that make sense? Any questions? Anyone want to jump in and interrupt me? Also, if you want to, feel free to say it's too slow or too fast. I have a feeling we've gone very, very slow today. I want to because I want to make it easy, but if it's too slow, someone should yell at me and say, hey, speed it up, Glenn. I don't get offended easily.
Well, I've got a question.
Sure.
Is there a way to display the variables that are being used in the commands? So
Yes. There is. In fact, that was not something we had a demo for before, but I just made a new demo today that will actually show that. One of your options for debug is actually for your variable. So you have two different key value pairs that your debug statement can take, and one of those is going to be for variables, and the other is actually for a message. And we'll see an example of that coming up soon. All right, are we ready for 10?
This one looks new.
10 is new. For those who've seen this before, we actually have a new example that I've created. So here's something that I want to show you. So we have some tasks, and this task is we've kind of started over. We're not including a lot of stuff. I had a lot of things combined, but I want to now just focus on a new concept. And so this new concept is simply 2 tasks, very simply. The name, of course, shows up just like before, but now I have a shell command. Again, shell is going to show change, and unless I happen to have made that on my remote system, which I don't know how I would have since you've seen me build that system from scratch, will that be successful or will that fail? Craig, I'm going to pick on you. What do you think?
I think it'll fail.
It will fail, but will the... Okay, it will fail, of course, because it doesn't exist. Now, will the playbook stop or will it continue?
It looks like it will continue.
It will only continue because I told it to ignore the errors. If you have a typical error in a playbook, it stops right there usually and says, look, you got a problem on that machine. There's no need to continue. Because you ideally want to keep them idempotent so that everything can keep running without an error. So an error is pretty unexpected. Here's one where I made an intentional error, and I actually said ignored errors is true. So if I were to run that, sorry, nothing else, I'm cementing in everyone's mind that we need to type Ansible-playbook, and yes, you can alias it if you wish. So here we go. We're gathering facts. We actually see, now see that red on the screen makes me think, oh, I broke something. Oh, it's okay. It still keeps going. But it definitely still shows you an error happened, but it ignores it. And so we know it continued because the next task said, do you see this? And we're using debug to show that you see this. So again, another simple example, do you see this? That happened because I said ignore errors. If I were to have erased that command, I no longer ignore errors. What happens now? So I'm running. Oh, no, I stopped. Look, I actually have a registered failure, so it stops. It doesn't go on. It shows me that something failed. That's an unrecoverable error. Something happened. Make sense?
So the fail refers to the Ansible command, not to the commands within Playbooks.
Yes, the failed refers to how many are you calling fail. And the Ansible, if you say ignore errors, then it's treated, that Ansible command is treated as successful. And also, notice something else. Notice that the failure actually gives you everything in JSON format. There is actually a particular code snippet in our repo that talks about Ansible and JSON and things like that for those who want to go see what JSON and Ansible and YAML are. But by now no one's asked. I assume everyone understands that this is JSON format, so that I can actually parse this pretty easily and very efficiently. And I can actually do things from it. In fact, we have other parsing that's built in.
There's that's the question on the screen.
Sure.
If fail equals 1, how is it ever possible to have failed other than 0 or 1?
Well, that's why it's a Boolean.
Or it is a Boolean?
Yeah, it's a failed as a Boolean. The 1 isn't the number of failures. I think it's the Boolean that fails. But good question. Okay, so let's look at 11. Now, I am not using an ls of a bad command. Now I'm going to use a pwd. Now, pwd, how can you ever go wrong with a pwd? I mean, unless you're in a bad... I guess you could if you actually deleted the directory you're in and tried a pwd. Some Unixes will complain. But this is obviously meant to be a command that is not going to fail. I did that on purpose. But I also wanted to bring in this concept of register. Register means that I can save the output of that command. And Craig, here's your question that you asked a few moments ago. In my debug, if I want to see the actual variable output, I debug and I actually just print out the variable that I want to see. And I just say variables password output. I'm actually going to show what that variable looked like and what got saved. And somehow, probably from doing that step that I just mentioned, I'm able to know what that output looks like and know that because it's a shell command, they have return codes. And return codes, what do we expect a return code to be of a successful command? For the Unix gurus around us. I expect it to be 0. Let's see if I'm right. So hey, Greg, look at that. This is the example that you mentioned earlier. Like, here's the whole variable being printed out. So the whole variable, not just the text. And the return code was 0, like I predicted. So that's good. Return code was 0. So we'll go back and look at that. In
Why
fact,
don't you see the output? So you captured it.
here's the output. This is what got saved. This entire JSON string.
But it's not saved as it appears usually within a PWD. It appears in the YAML format.
Your standard out is. Look at all the wonderful information that we get.
More than you want.
Yeah, more than you want. That's a good way to say it. Yeah, sometimes it does give more than you want. It gives a ton of stuff, more than you probably need. It gives you return code. It gives you the standard input. Every command that you're running, every shell command. Remember how we were just running shell commands?
No, but I thought you were asking it only for the output of the PWD command.
Let's go look at that playbook. This is great. Number
11.
Thank you. So the registered value, I'm asking it to save the PWD output. I called the variable output, which might be throwing us off because that's all I cared about. But this is actually the registered of that command. It could be complicated, it could be not. So when it actually does this shell module, it saves a whole bunch of stuff. All of it's available to me. So it's not just me getting like output and return. I mean, I can actually look at return codes. I can look at everything else. When did it start? When did it end? Did it change? Look, shells always show as true. So that's why. When did it start? How long did it take me to run this command? I could actually just look at start minus end. So start minus end and actually get the actual time. Or if I was super lazy, I can actually just look at the delta. So I can see how long it took. I can actually see what the arguments were to the shell. I can see what module executed it. I can actually see what my standard error report was. I can actually see what my standard out was looking like, which is really what I cared about. Or I should get my error, my return code. In fact, now I realize that we're actually looking for that output. I'm going to change this example for the future to actually not just be return code, but have another example that actually shows standard out. You want to do it live?
Then it would be 2.
Let's do it live. Let's be bold. It's a live demo. What can go wrong, right? I say that jokingly if you would realize how much I am paranoid of live demos. Things always seem to break in a live demo. Let me make this a little wider. Anybody else? The nice thing about pair programming, though, in live demos, when I have people who are brave to catch my mistakes, and that makes it catches the mistakes. I think this is going to work. Oh, except let's not say return code.
Yeah.
Let's say the output was. Okay. What do we think?
Looks
Someone-
good.
Oh, and we had someone online also telling me 0. Thank you for saying that. Earlier I asked the question, what was the return code, and I didn't see there was a question. My apologies, but yes, you're right. Return code 0. Excellent. Thank you for saying that. So now, if I run this, let's see what. Let's just up arrow over here and see. Did I save the file? I think I did. I think so. So look, the output was this. Does everyone see?
But you should have got the return code too.
I didn't. Return code came in that task, and output came in that task. And I have a debug for return code and a debug for the output. So I made 2 different debug tasks that would actually tell me the return code and output. I like that example so much. Thank you, everyone. I will commit that into the develop. It won't be in. I will actually put it in a .1 of this particular repo. It's a very good suggestion. Excellent. I'm going to assume that there are no more questions and that this is at an okay pace, not too fast or too slow. It feels like I'm going incredibly slow today, but because I've done this enough times, it's never a safe option to follow what I think. Okay, so I'm going to assume that we're good, everyone. Especially if you see my live demo I did. I condensed this all down to very, very fast. Okay, to the point that, you could hardly hear me. I was talking so fast. All right, so now, what is this? I'm throwing all kinds of things at you. Did I not show a when? Did I skip an example? Oh, this is a filter example. Sorry. I realize that I'm trying to show you filters. Okay, so this example, look what we've done. Our previous example was just really a copy and paste from the previous one to show you that all we're doing is grabbing the output of that pwd command. And it's really all of this stuff with different start times, of course, and things like that. But the basic essence of what's on the left. Now I'm going to say, let me use this previous thing that I just did with filters, and actually let me show you what a filter is. For those who are used to Jinja or Django templating, that are used to seeing these two things to denote variables, these two together as variables, you also know these are filters. So I could pull out the return code and say if the return code is 0, then do something. Or I can just rely on this to return it. A success filter will look at that JSON output and give me a Boolean of yes, a true, or a false. So if that output from its determination was successful, like return code is 0, no standard error, whatever it's using, then that will be true. But look, you guys remember? I recall something that I knew it wouldn't work. I'm also registered that bad example. But I wouldn't get anything else if I didn't ignore errors. I have to ignore errors so that I can actually proceed and see the next part that I'm trying to show you. So this variable is called a bad file example. This variable is called pwd output. I expect pwd output to be successful and bad file example to be failure or failed. Okay? So now let's actually look. So this is going to be just another debug, so you can see how debug can be very handy while trying to figure out how to do stuff. So was it successful or not? This is going to return a true or a false. What's the vote? And this time I'll look for anyone who's actually answering online. What's the vote? Someone want to be bold? Was it successful?
It's going to say false.
It's going to say false. So I like that. It is going to say, was it successful? We should say false. Did it fail? What should we see here? We should see true. Excellent. Let's run this and find out. My number is 12, right?
Yes.
Okay. And so, gathering facts. Oh, there's that really nasty error message that we're ignoring on purpose. Oops. Highlighting here to say ignoring. Was it successful? I can't remember what everyone said. I think everyone's... Yes, that's what everyone said. Good. Excellent. I have a very small cache. I can remember things in theory really well, but if you ask me a number in 2 seconds, I'll be like, what did you just say? And true was what we said. So does that make sense? We can use these filters. This is a filter that we can actually use to do things. So we can start having some conditionals. Now we have a real Boolean. I mean, they're not just the string true and false, they're actually the Python Booleans. You can actually conditionally do things with them. So let's look at 13. Any questions online? Nope. All right. 13. Predict this output. Someone tell me. Someone be bold, not just me sticking my neck out. Predict this output. What do you think will happen? All right, I'm going to run it while we're waiting for me to pick on you. Say you answer that question. So we are going to, this is about a when statement. When something is true, oh wow, and I didn't even use the Python version, I actually used the built-in YAML. It's smart enough to say yes or no. It actually has built-in code that actually say yes, one, true is a string, lowercase, all of these things it's able to interpret to know what you meant. I was meaning to be more clear by using an uppercase F, but there you go, you don't have to. So when it's false, it's going to execute this module. Well, it's never going to be false. So basically I'm saying is don't do that statement, because when will only execute when this is true. False is never true, so this thing will never be processed. On the other hand, this when is true. This when will execute whenever the stuff on the right is true. The stuff on the right is true, so this when will execute. So it will execute this guy right here. So, and I use guy in a very, very non-gender sense. You know, seriously, I will say guys for people of all type, of all gender. So this particular section of code, debug, will execute because that when is true. That statement is true. Let's see. So predict this output, skipped. Predict this output is skipped. And maybe this output is presented. So you can see that when this particular piece of code is there, when this particular thing is false, that code is skipped. Does that make sense? I think I stumbled around that. Hopefully that made sense. Do I see head nod? See something else about having people here with me is I can see head nodding. So I think that's good. Yeah?
Yes. Makes sense.
All right. Thank you, Craig. Awesome. So we actually see that predict this output ran. No, predict this output didn't run, but maybe this output did because of the when. So all about when. I can put more complicated things over on the when side. Let's look at 4. This one is tricky. This is like your final exam. What is this going to do? And I'm not going to run it yet because I think we need to pull it apart and think about it. So the first thing it's going to do is ls a temp, what I'm going to call super crude lock. Assuming I've never run this before, will that ls command be successful? And you don't have to use ls. You could actually use your shells to come up with Boolean stuff to look at return codes and see if they're successful. You don't have to use such a crude ls way of doing it. I'm just illustrating some points. A lot of the things in this repo are all about teaching, not necessarily how you would do it in production. So, hi. I have a question that says hi. So we answer hi back. Very good. It's good to talk to you. Okay, so now the question is that ls command, will it be successful? I need someone to say yes or no.
Yes, because you're going to ignore the error.
It'll be a successful unit. Yeah, it's a tricky, even the way I've worded it's very tricky or not even clear. It is, the ls command is about a file that doesn't exist if I've never run it before, assuming it hasn't been there by something else. So it normally would fail. That's not how you necessarily look at things. In fact, I need to rewrite some of my examples before inside, where I actually do look at that ls and look for results of failure. But I register the results, and then from that, I basically say, look, I'm going to print the word fizz when, and see how I'm combining things, when super crude lock of success. So when the super crude lock is successful, then I will get fizz. And when super crude lock failed, I will get buzz. So I'm going to get one of those things out on the screen. What do you predict? Fizz or buzz? Fizz or buzz, anyone? Which is, so this is the failed one. So we expect to see buzz. All right. I'm going to run that while we are waiting, as everyone can see. We're expecting to see buzz and not fizz. So I see the message. Fuzz was changed, and we see buzz. So there we go. Buzz is what came out. So exactly right. I'm going to run this again, and I should get the exact same output. Agreed?
No.
Ah, someone says no. Someone's not falling for it. I asked the question.
Touched it, it's there now.
Exactly. Because I touched it, it's there now. Therefore, I get a different output. Now, I actually should see fizz. Is this the best way to do it? No. In some of my later teaching examples, I actually did do it this way, which I need to change. Someone asked me in a session a couple of times ago, do you have to do it this way? And I don't even know why I even thought to do it this way. But it is good to show you. Do you ever need to parenthesize in the shell command? Do you ever need to use print? Oh, here, let me select the question so people know where it is. Someone just predicted that the answer was buzz. Very, very good. So the answer was buzz. And if you rewind just a few seconds, you can see the output of that. Very good. Thank you. Another question from online. Do you ever need to use parenthesis in the shell command? Oop, sorry, selecting the question now. Do you ever need to use parenthesis in the shell command? If you would need to, normally you could. There are times that parentheses mean something special in the shell command, so it is possible. But I don't see any reason for the examples that we're having now. Oh, quotes. Sorry, let me answer that. Sorry about that. The actual question was, do you need to use quotes in the shell command? And the answer is, if you would need quotes normally, like if you're typing that on the regular command, sure, you would need to. For example, if I'm touching a file that has spaces in it, like you can create a file with spaces inside of the file name. I generally wouldn't, because it's very confusing for people. But if I did that, then you have to put quotes around it to say, look, that's not, don't, as a shell command, separate on the spaces between there. Treat that as a whole file name and separate on spaces everywhere else. Hopefully that answered the question. Let me know if it didn't, and I will just keep trying to answer it. But the answer is sometimes if you would need those quotes normally, if you would need them for a shell command that has quotes in them. Okay, so very good. I think I'm getting the hang of how to answer questions. This is a new one for me. Thank you, everyone, for being patient with me on that one. That was very cool. So that was a very tricky one, and like I said, it was the final. Where am I? Let me actually not type in my Hangout window, but type in my shell window. And so we have done 14 examples, and some of those are new examples that you, some of you who have done this before, as I had several people say, oh, those are new, keeping you on your toes. So that is roughly how you could do playbooks. But it's not only the scratching the surface. We started very, very basic. And that very, very basic and fundamental beginning was to be how to do SSH commands across through, the -T option. And then we said, okay, you could use the Ansible command to actually run commands through lots of machines. So we said, look, Ansible can do more things like modules, and we can see what it does. Modules has lots of things, not just a little output, but quite a bit of it, and a lot of things that you can parse and get information on. And then we said, that's still not enough. Let's actually look at playbooks, and let's start looking at how we include playbooks. In fact, there is a playbook that's here that I did not write. I took it from this gist from GitHub, and I want to get sure I have to give Fred all of the credit for doing that. So that is. I didn't write it, Fred did. And I'm not asking you to go through all of this. Frankly, it's actually a little old now with the current version of Ansible. But it does give you an idea of what's there. You can see there's a host section. You can see some examples. Lots of comments in this playbook. You can see that sudo is there. You can see something called a remote user, so that you have such things. You can actually see how we can call playbook attributes with variables. And it just keeps going. But really, every playbook that we've seen has had a couple of basic things. What are those things? So we have seen one of them is a task. So let's just, let me just write them down here. I'll do it here. So task. What else have we seen? What was a special task? Handler. Or handlers. So task and handlers. What else? We had variables. What else was in our playbooks? We had lots of different modules. So they were including yum, debug,
not capture, but
shell, built-in, so register.
Register.
So we also had things like register. Lots of different things that we can use within our tasks. Modules can be used within task, and built-ins can be used, spelled properly, built-ins inside the task. I don't know what to call them. I'm calling it a built-in. That's probably the wrong word. And our playbook is going to have task and handlers and variables. What else does our playbook have? Is there anything else? 1, 2, 3. I guess that's probably mostly what we've covered. What if I wanted to be able to handle files? There are actual different things that handle files too. If I wanted to upload certain files, I could. And if I had a particular file in a location, I can say that particular module is give me the source, like where is it on your system, give me the destination, where is it up on that destination system, and a file permissions and things like that. So I can pretty much just take entire files. But variables are special because they give us the dynamic. Task and handlers are the things that do things. Handlers are special tasks in that they're called when tasks are run. When a task notifies a handler, it's executed. A handler doesn't execute otherwise. But there's also, not only is there a special file, but there's also, very much like handlers are special tasks, templates are special files. And templates are really just files that you can upload and do things with too, but you can actually put variables inside of them and they'll be processed. So files is a flat, you can just have a file that doesn't need anything. Templates can be processed. And those can all be in playbooks. And we import playbooks, and we can actually use variables when we import playbooks. But there is yet another level. Okay? So let me go to the final part that we're going to cover today, and that is role examples. So I am in the Ansible tutorial source under role examples. And so in the Ansible tutorial source role examples, we're going to learn about something called roles. And we're taking all of the concepts that I've used, and we are building them up. My first demo actually builds an entire Python virtual environment on the other machine. What does it do? It creates a new remote user called web user, which was a variable that I could change to something else if I wanted to. What else does it do? It actually uploads a virtual env environment like command line file. So it uploads it. It then extracts that file with tar and does some other stuff with it. And it installs a virtual env. It makes a bash profile and uploads it into the right place so that I have a .bash rc so that if I ever wanted to, I just log into that user and I automatically get that virtual environment. It does things basically that gives me a remote, isolated Python environment. I could have just simply done a sudo install on Python on the root system, but this gave me a chance to demonstrate an isolated environment. So it's just a way of demonstrating lots of different tasks. So telling you all of that, how big do you think this, I mean, that's a lot of stuff, right? Someone say that's a lot of stuff.
It's a lot of,
It's a lot of stuff. So, I can tell some of you have been to this one before. So how big do you think, and someone from online, Craig, you have to be my guinea pig on this one. People here have actually seen this one part before. How big do you think this playbook's going to be?
I have no idea.
It sounds like it's going to be big though, right?
It does.
All right, let's take a look at it. Wow, that's pretty small. So we have a new concept. So a playbook can also have a playbook can have tasks as well and roles. So and host and lots of things and names. So this playbook has a name. In fact, while I'm doing this, I should let this playbook run because a lot of things are going to take longer. So let me in this window go to playbook examples. I'm sorry, let me go to role examples, and let's do Ansible playbook as well. Demo role 1, and while that's running in this other window, we can look at this. So it's basically doing the idea of a role, and a role is kind of like take all of those things that we learn for playbooks and break them into pieces and put them together into certain ways. So let's look at a role. I have several roles in this repo. I'm in role example roles, and you can see that there is a role here called Python stack. And if I were to cd to Python stack, which is the only role that I'm installing, hey, wait, we just looked at something like this. Variables were on top. We had a bunch of variables to be dynamic. We have files because, we had tasks. That's what we used a lot of. And we had handlers, which were special tasks. We also had files. I mentioned that files is going to be, files you want to upload. In fact, if I just looked at files, we would see that I have one file, that virtual environment that I upload. It's really, really simple. And then I also have templates. And, oh, I do have a template. Good example. So let's look at that template. So that template is really just a bash RC file that really does nothing. It just adds a source, of my home virtual environment that I made. But look, I can use variable substitution as well. And we will see that when we go look at that machine. So really, we've talked about everything that you can see in a role except for one thing. What thing did I miss? Yes, meta. Very good. So inside of meta, all that is a way of kind of, if you were to extract this role into, break it into all of its pieces, and then say, okay, now this describes these pieces. Typically, there is nothing in my meta here, but we will see that there are other metas, especially when someone asks the question, which comes usually later if I forget to say anything, is like, how do you get one role to depend upon another? That's a perfect question to talk about meta. All right? So it executed over on the other machine. We actually see all of these things happened. It executed on the other machine. We actually see that, look, I do the ls thing. Could I just check to see if the file existed instead of doing ls? Yes, of course I could. But this is almost the exact same pattern. In fact, in the future, I think I'm going to take this away. Now we have the other examples. We don't need to show this here. But so we actually see if the virtual inf was already installed by just looking to see if that was already existed by just looking at that file. And if it wasn't, we just created the virtual environment, and then I did something where I removed access to the web. I temporarily gave, in a very non-secure way, I temporarily gave that user I created, all of EC2 users, access so that I can keep it simple for the demo. And I did that with a custom-written module, which we will learn at some point, but today is not the day for custom modules. We're just doing an intro first. Custom modules will come next at another session. All right, so that is what a role is. And if I want to include a role, I would simply just say, look, my web servers need to have a Python stack. And this is where I start saying, okay, and this is where you start thinking in a higher level. My boss came over and says, look, I need you to have 12 different servers, and I need you to update just the Python servers, or I need you to just update Ruby on Rails server as an application server. I need you to basically make a web server differences, or use LLVM to create your own custom snapshots to do something with the database. So I can have several roles here. It could be a Python stack. It could also be, I could include another role where it actually says database. I could be a database server. So it doesn't make sense since I already called them web servers my host, but typically not a good idea to have them on both, but just for an example. I also could say that this is a memcache server. So I can do things like that where basically whatever host that I'm talking about could have these roles, or I could basically take these roles and designate host later. All right, but that example was just one particular role. I kind of threw a lot at you. And if we want to see real quickly what that Python stack roles looks like, let's go look at tasks. That's the best place to start. Every one of these is a directory. I like keeping a directory even if it's empty, just so you can see all the components. So that's why I've done it this way. There are some things here like metadata are empty. You can have several files. I don't have to have each one of them. But if there is a main.yaml file in one of these designated directories, which are special to Ansible, then that's actually what's going to be used. That main file is kind of like a main part in C code, or if you sometimes do like if name equals main in Python code, or something similar in Ruby code. Main just means this is where I'm going to start. And okay, this is where it got complicated. So it is an include. Look, I've just uploaded my virtual inf environment package. This is that copy. And look, I can now introduce a new service, a new module. Copy module is going to come from a source to a destination, setting an owner and a group, and look, at this point I start making everything variable based so that I can change it later. So putting all those concepts together, you can do a lot of powerful things. Okay, and I upload the bash RC file. This one's different than the copy because it's actually a template. So this is a template where it'll actually process the .bash RC file. It'll put it into whatever user I dynamically created earlier, .bash RC. The owner will be that user, the group will be that user, the mode will be 0600, and I needed sudo. All right, have I overwhelmed anyone yet? We're coming to an end, so speak now. All right, so let's look at this other role. We have only 3 roles to look at, so let's look at this other role. It's the same idea, but, oh, I skipped roles. Don't look at that role. Look at this role. So this role is the same thing, but I've now basically said that this is going to be a web server Nginx. So my web server, this makes sense for web servers. You probably say, look, it's going to be an Nginx server. It might also be an Memcached server or something like that. So if I were to come over here and play that while we're looking, it will start installing Nginx. Now, as a quick reminder, while we're waiting, where's my screen? I might have moved it. If you remember, we actually said, hey, look, we are running Nginx. This is the machine that we had. We actually had Nginx running in the services, but it was like the default. It's like install it out of the package, start services, and change nothing, and you get that really boring type of service. And as we're seeing that we're actually starting to upload things, look, I'm uploading some Nginx configuration files. So I can configure Nginx by a set way, and when it's finished, I'm going to reload my Nginx, and what do I see? Ho-ho! 500 pages are bad, right? Well, yeah, okay. But it's a cool 500 page. We expected that in my demo. And what's cuter than a kitten? I mean, not all 500 pages can be bad, so, you know, all of this stuff is being served from that stuff. So I didn't have to go in and configure that by hand. I basically said, here's a recipe, go put it up there, and kitten's in my recipe. Where are the details? It's been a while since I looked at it. I'm sure we'd have to go look in the, just look in the role. It's broken down into those organized pieces and follow the tasks and look for the files that would upload something. And, you know, so you can actually have other things as well. So it's really just a 500 page. All that was is to show you, look, I just installed an Nginx. I could customize an Nginx file,
Well, why is it a 500? Because you actually got a response.
Because I configured it to have an upstream. I configured it to have a 500 on purpose because I wanted to do the next example. Basically, it's a 500 because there's a piece missing. It's expecting Django to be running. Django's not running, so it says 500. So, wouldn't it be cool if we could make Django run? We can get rid of that kitten. I'm sorry, no, we don't want to get rid of the kitten. We can get rid of the 500, I'm sorry. So, look, I had Nginx there. It'll do it all over again, the same thing. Hopefully it's a idempotent, so it doesn't matter to do the same thing twice. But it also is going to install the Django server as well. All right, and so I'm going to run 3. Since we're winding down, we have about 10 minutes left. And while that's running, I'm going to take a look at these other examples. I just set an Nginx role. So let me go look at Nginx. Sorry, I thought I was there. So now let me look at the web server Nginx role that I made, which is really just all these complicated things on a higher level that I'm not going to talk about because it's like a playbook that's broken into pieces that I can chain together. So it's like a meta level of playbooks. And showing this meta level of playbooks, I'm going to go look. Oh, I have something inside of my web server. Look, my Nginx depended on a Python stack. Why? Just to show a dependency, and that's how I created this. Because I was actually showing that we were going to install and need Python for something. So that's what meta is used for, and we could go look at these tasks and we'd see very, very similar ideas. So we would just see the same thing over again and over. You have files, which your files are uploaded, handlers, which is starting and stopping services typically is all it's ever used for. Meta to show dependency between things. Tasks, the main core of how things work. Templates, which are special files that can have variable substitution, and the variables that are used for everything. In fact, what are my variables? Let's look real quick. If I were to look at my variables, wow, I didn't have any variables for this one. Interesting. I thought I would. Oh, but I know it includes the Python one, which had all of these variables, and that's why, because I already defined everything here that I needed. Most of those variables were just where to put virtual environment, because I had a Python stack, just to show that we could. Again, I wouldn't necessarily think this is the most productive way to do something in production. Okay, so if that's said and done, I should have mostly a running machine. I originally cut off the rest of my slides when I made this a shorter talk, so it doesn't start the server automatically. So I'm going to do that now. Let's see. What is my machine? My machine is my Ansible config. Will show me where my keys are, and my Ansible and where my host is. And my Ansible host I know that beep's annoying. I'm sorry, I didn't think to turn it off. I am going to SSH that machine just like we did before, except I pressed enter too soon. Sorry about that. And I'm going to go to EC2 user just to show that I can, and go to this web server. Now, I logged in with that key. Really, at the end of the day, though, I said that there was another user. Oh, I guess there is. There is a web user. I created that as part of this whole script. So why don't I just switch to that user? I wouldn't recommend this generally. I'm just showing you that this is how it is. Typically, you would create credentials and log in and create keys. And someone asked earlier, could you ask for password prompts? Yes. You could do something like that for keys. You could also actually have encrypted bags to store things so that things don't get in your repo just normally. But I just logged into that user. And wow, my virtual env also had started automatically because I have a bash RC file. Well, it knew to activate my bash RC for my virtual environment. So that's all pretty cool. And I have a sample project. Oh, and there's a Python manage command. How can you not just try to run that server to see what's happening? Just to make Django run. Now, would you do this in production? No. There are about 5 or 6 other things. I was just trying to keep the repo short because it could go really long to get into lots of things you needed, like a supervisor to start automatically and some. But there is a manage service already built in. So other things you can do. But I'm trying to give everyone stepping stones so that they can actually launch into their own learning how to use Ansible. And that's pretty anticlimactic, but it worked. I think the kitten was better. So at the end of the day, we learned a lot. I tried to make it on building blocks only. I tried not to throw the whole thing at you. When you learn, they don't give you a progression of how to start. They say, here, you learn things, you'll jump between things. I intentionally focused on the progression because I think that's what most people would still need. Everything else there's really good documentation for. So can you, if you build your own Ansible tasks? I think so. If you go look at this repo, learn from it, play with it, get a sample machine, you could learn how that worked. Could you be able to start from scratch and do everything in 2 minutes? Probably not. You're going to get stuck with it. There are lots of questions that people have. For example, people ask me all the time, what happens if you want to try to have your own dynamic host? Most people want to start with that. They already have an infrastructure they have to support, and that infrastructure already has machines everywhere. How do you handle that? And that's where most people get stuck because there's so much complexity there. They don't actually get to learning this piece. Or for example, they try to start an EC2 service with Ansible. You can do that too. You didn't have to do it through the web prompts. We could simply have done EC2. That's actually just like we had shell and Yum and all of these things. There's actually a module called EC2. So you can actually start a web service from scratch, register the details of it, and then use it later. So you can actually start from nothing, play the playbook, and start an entire machine up from scratch. But I also didn't want to make this repo at all related just EC2. I wanted people to be able to use it anywhere, and I didn't want that dependency. So if you can use this with OpenStack, and it works just fine. And I think I think there's OpenStacks as well. There are other ways, there are other modules you can do to spin up other instances. If you're trying to handle your host file itself, if your host file has an executable flag on it, Ansible's going to try to execute it and not just read it as a text file. And however it executes as a command line, if you actually come back at the end and actually just the outputs, it'll take whatever's sent to standard out, and treat it like JSON. And if it can parse that as JSON, then whatever you've done for managing your host can be done that way. So you can customize anything. All these other modules, LDAP servers, tons of things you can do just because it's very modular that run a process, grab the results from standard out, treat them like JSON to parse them. And if you can get that from host and sections, that works fine. If it's not executable, if it's a file, then it'll just parse it through like the standard Windows INI type of config for files. What do we think, everyone? We're right at 2 hours. I gave a lot of information, maybe too fast, maybe too slow, but hopefully very, very useful. A couple minutes for Q&A. Now's the time to pop in for Q&A before we end the broadcast. This is recorded. As far as I know, if Google doesn't have a mistake, then this will be recorded for anyone to be able to review after the fact, and I can also send any links that you need. But Q&A? All right. I really, really appreciate everyone's time on a day like today. I think people actually had, Saturdays are a tough day for people. People have things they want to do on other times in their life. Evenings are better. Happened to be that this one was on Saturday, so we can try to do it another time. All right, I'm going to go ahead and hang up now, or at least stop the broadcast. So thank you very much for everyone. If you have questions, well, I'm sure we will find a way to, as a group, do a lot of Q&A for you. And the video will be available after the fact for anyone who needs it. Take care. Have a good day.